To find trig values of special angles, that is sine, cosine, and tangent of special angles, it helps to see a bunch of different ways on how to memorize it. Sometimes we can use a unit circle, sometimes we can use a chart, and sometimes we can use our hand. So looking at the graph, we can see that whenever we have 30 degrees, which corresponds to pi over 6, it has the x-coordinate and the y-coordinate as listed here. And we have all those values listed, and it helps to think of cosine as the x value. I can write that down. Cosine is the same thing as the x value, and sine is going to find the y value, and tangent will find the y over the x value. So for example, if I were to take cosine of pi over 6, cosine is the x-coordinate, and the x-coordinate of this point is 3, or square root of 3 over 2. If I was to find the sine of pi over 6, that would be the y-coordinate, and it's therefore 1/2. If I want the tangent of that value, I would take the y-coordinate divided by the x-coordinate. The 2's would cross cancel, and I get 1 over the square root of 3, and you can simplify that to the square root of 3 over 3. I can show more about how this is calculated in the table down here, but this is a great visualization of where it happens on the unit circle. It's worthwhile talking about all the 5 different numbers that show up on this entire graph as well as this table. Let's do that now. So there are 5 numbers. Here they are. Notice the pattern here, how the denominator is always 2 and the top just increments by a square root of 1. So square root of 0, square root of 1, square root of 2, square root of 3, square root of 4. So I'm going to simplify all these to see what they really are. When I have the square root of 0 over 2, this is simply 0 over 2, and 0 divided by anything other than 0 is 0. The square root of 1 over 2 is simply 1 over 2, or 1/2. The square root of 2 over 2, that can't be simplified. It's still the square root of 2 over 2. Nothing can be done. The square root of 3 over 2, again, nothing can be done. It's just the square root of 3 over 2. And the square root of 4 over 2, the square root of 4 is 2, and 2 divided by 2 is 1. So really, our final answers, let me box all of the final answers that you'll be seeing. These are all the numbers that should be showing up on our graph over here in the table that we're about to create. You can see 1 and 0 definitely show up there. Square root of 3 over 2, 1/2, and the square root of 2 over 2. Those are the only 5 numbers that you need to remember, aside from making them negative. Again, you're negative in terms of the x if you're on the left side of the graph, and you're negative in terms of the y if you're on the bottom part of the graph. So let's go ahead and turn to the table. This is one of people's favorite ways to memorize their trig values of special angles. So when you do sine, you're literally going through all of these different values in order. And I should mention also that these are in order of size because you're incrementing, getting larger and larger and larger. So I really don't think of 0 and 1 because I know that 1 is the largest and 0 is the smallest. From there, I'm going to say that I have a small value here, a medium value here, and a large value here. I can call this one extra small and extra large if you want to have sizes on everything. But really, this 1/2 is small, medium is square root of 2 over 2, and large is square root of 3 over 2. So sine is going to progressively go all the way up. So we have 0, we have 1/2, we have square root of 2 over 2, and we have the square root of 3 over 2, and finally 1. Cosine is going to do the exact same thing. It goes from extra small all the way to extra large, but in the reverse order. So I'm going to kind of start from the backwards. 1 is the reverse order, so I'm going to go 1, then square root of 3 over 2, and then the square root of 2 over 2, 1/2, and then 0. And tangent, as I mentioned before, is the y over the x. It is the y over the x, which is the same thing as saying it's the sine over the cosine. So if I'm doing sine divided by cosine, if I'm doing 0 divided by 1, 0 divided by 1 is 0. If I have 1/2 divided by square root of 3 over 2, again, I've said this out loud that the 2's will cross cancel. I want to show why that happens really quickly. So if I have 1/2 and I divide it by the square root of 3 over 2, whenever we have fractions that are being divided, I'm going to keep it, change it, flip it. If I keep the first fraction, I'm going to change the division into multiplication, and I'm going to flip the second fraction or take the reciprocal, and I'm going to get 2 over the square root of 3. And notice that these 2's do indeed cross cancel, leaving you with 1 over the square root of 3. The 1 over the square root of 3 is not simplified, of course. You have to go a little bit farther, and I was going to talk about it up here. I guess I can talk about it right now. 1 over the square root of 3 is the same thing as, well, I need to get rid of the square root in the denominator. To rationalize the denominator, I'm going to multiply the denominator by the square root of 3, and therefore I'm forced to multiply the numerator by the square root of 3 as well. The denominator is now the square root of 9, and the top is the numerator is the square root of 3. And then from here, the denominator simplifies to just 3, which notice it has been rationalized. There's no square root, and the numerator is the square root of 3. So it's a lot of work to show all of that, but it is indeed just the square root of 3 over 3. For pi over 4, notice the same number divided by the same number, which is just 1. And to get pi over 3, I'm doing the square root of 3 divided by the 1. Again, these 2's get canceled out. Whenever I divide by 1, it's as if I didn't write anything. It's just the square root of 3. And then finally, if I do 1 divided by 0, I can't do that. So this is undefined, or usually I just leave this as a blank spot. You cannot do that. So this is a great way to memorize all of your trig values of special angles as well. Remember that if you are on the left part of the graph, I will say the left part of the graph is negative, and if you're on the right part of the graph, you're positive. Same thing for sine. If you are on the bottom part of the graph, you are negative. If you're on the top part of the graph, you are positive. And for tangent, it's interesting. If you're in quadrants 1 or 3, you're positive. And maybe I should move that over here to keep all my positive and negatives on the same line. And if you're in quadrants 2 or 4, then you are going to be negative. A good way to remember all of these in one simple table is all students take calculus. That means all students take calculus. This is a great mnemonic to remember that everything is positive in the top right, sine is positive in the top left, tangent is positive in that bottom left, and cosine is positive in that bottom right. Moving on to a method I am not familiar with and I actually learned from YouTube recently is how to do sine using your hand. So if you got tattoos, you could totally put a 0 on or in a pi over 6, all these values on your fingers, and you'd be like super duper, I was going to say cool, but now I'm just going to go with nerdy. If you have that, then you can use this to figure out what trig values are for special angles. So for example, if I say I want to find sine of pi over 2, for example. Well, then I would look at my finger for pi over 2. I would count the number of fingers to the left. And I'd say, okay, there's 1, 2, 3, 4 fingers to the left. So this is going to be the square root of 4 over 2. The square, so I can write out my work to show you what I'm thinking in my head. This is the square root of 4 over 2, which is 2 over 2, which is 1. And indeed, sine of pi over 2 is 1. What if I want to do cosine of pi over 6? Well, cosine of pi over 6, it's the fingers to the right of pi over 6. So if there's the pi over 6. How many fingers are to the right? 1, 2, 3. Therefore, the answer is going to be the square root of 3 over 2. Done and done. What about if you want to do tangent? Let's give an example. I want to do tangent of pi over 4. This one's kind of fun. Pi over 4 is this middle finger. Give them the pi over 4, guys. And then you can say, okay, the fingers to the left is, there's 2 fingers to the left, and the fingers to the right, there's 2 fingers to the right. This is going to be equal to the square root of 2 divided by the square root of 2, which is just 1. And again, you do have to sometimes rationalize your denominator. Be worried about this one whenever I have my tangent of pi over 6, because it is the square root of 3 over 3. There was a bit of math that we had to do to solve that. But this finger method is really, really cool and does work for all of your special angles, as long as we remember all of these tricks, or all of those tricks as well. That concludes all of the different ways you can find trig values of special angles. Thanks for watching.